The Carolina Bays gained attention in the 1930s when aerial photographs revealed their regular elliptical shapes and their northwest orientation. The origin of the Carolina Bays has been the subject of vigorous controversies between proponents of impact hypothesis and those favoring terrestrial mechanisms. I am Antonio Zamora. This presentation is an overview of my paper, A Model for the Geomorphology of the Carolina Bays. The Carolina Bays are shallow elliptical depressions with raised rims on unconsolidated ground whose major axis is oriented toward the Great Lakes. The size of the bays varies from about 100 meters to several kilometers in size. The bays are found on sandy soil close to the water table along the east coast of the United States. LiDAR, a laser ranging technology, greatly improved the visualization of the Carolina Bays. A geometrical examination of Carolina Bays with clearly defined rims show that they have average width-to-length ratios of 0.58, and each bay can be precisely fitted with an ellipse whose ratio of minor to major axis corresponds to the dimensions of the bay. The width-to-length ratio corresponds to cones inclined at about 35 degrees. The Nebraska Rainwater Basins are geometrically similar to the Carolina Bays, and they are also oriented toward the Great Lakes. The Nebraska basins have been greatly degraded by water erosion and covered with wind-blown dust, but the ellipse-fitting procedure can still be used for the basins that have maintained well-defined borders. The similarity of the Nebraska Rainwater Basins and the Carolina Bays makes it possible to consider that they were created by a common mechanism. In 2010, Davies and Gilbride used Google Earth to integrate hundreds of LiDAR images of Carolina Bays and Nebraska Rainwater Basins. Great circle trajectories, adjusted for the Coriolis effect, produced a convergence point in Michigan by the Great Lakes. Previous attempts by others to find the focal point had failed because they had used straight lines on flat maps and they had ignored the flight time of the projectiles. My paper introduces the Glacier ice impact hypothesis and identifies four mechanisms that are necessary for the formation of Carolina Bays. First, a meteorite impact on the Laurentide Ice Sheet ejected ice boulders in ballistic trajectories. Next, the secondary impacts by the ice boulders liquefied unconsolidated ground close to the water table. Then, the oblique impacts of ice boulders on liquefied ground created inclined conical cavities. And finally, viscous relaxation reduced the depth of the conical cavities to produce shallow elliptical bays. The speeds required to launch ice projectiles from Michigan to the east coast can be calculated using ballistic equations. Speeds from 3 to 4 kilometers per second are necessary to reach the east coast. All the trajectories are suborbital space flights with a substantial portion in the vacuum of space. Any liquid water ejected above the atmosphere would have produced clouds of ice crystals that block the light of the sun. Scaling laws relating crater size to impact energy indicate that a bay of 1 kilometer would have been made by an ice boulder with an energy of 3 megatons of TNT, which is equivalent to a 7.54 magnitude earthquake. A smaller bay of 220 meters would require an energy of 13 kilotons of TNT, equivalent to a magnitude 6.0 earthquake. Seismic vibrations of magnitude 6.0 or higher are generally sufficient to liquefy saturated soil. Experiments confirm that oblique impacts by ice projectiles on liquefied ground can create inclined conical cavities, and that viscous relaxation reduces the depth of the cavities to form shallow elliptical bays with raised rims. Overlapping bays are created by adjacent impacts. My paper proposes that the Carolina Bays were produced by a saturation bombardment of glacier ice chunks ejected by an extraterrestrial impact on the Laurentide Ice Sheet. Water ejected above the atmosphere would have produced a cloud of ice crystals that block the light of the sun. Thus, the formation of the Carolina Bays has to coincide with an extinction event on the eastern half of the United States and the onset of a global cooling event. This combination of conditions happened approximately 12,800 years ago. Further study of the Carolina Bays may provide detailed insights about the late Pleistocene epoch and reveal information about near-Earth objects that could destroy our civilization.